Hello, hello.
Hello,
This is
Seve.
a talk test.
This is a talk test.
And
I'm
a
not
dance
wearing
test.
I'm not wearing my regular outfit. I've added an orange jumper today. I'm not sure.
MacPack. What is MacPack?
MacPack's a Kiwi brand that does outdoors gear. So I've got a MacPack tent and a MacPack orange poly fleece.
Is Kiwi a really big brand that I should know, like Patagonia or something?
New Zealand.
Okay, a New Zealand brand.
No. Like the Kiwis are New Zealanders.
Oh,
It's Australian, or
it's
I
a
guess
Kiwi
Alpha.
brand meaning a New Zealand brand.
Yeah, exactly.
Okay, all right.
Yep.
Huh, interesting. I've been meaning to go to New Zealand. I did a road trip in Iceland.
Mm-hmm.
We did we rode all through Iceland. You can get a camper van and just ride the entire outside of it. And
That's
it took us 2 weeks. But you could do a similar thing in New Zealand, I'm told. Good camper van culture.
I plan to.
It looks really beautiful. I believe, I'm going to get this wrong, but I believe Lord of the Rings, maybe?
Yep, indeed. Yeah, the Lord of Rings and the Hobbit.
Yep. Yeah, it looks really pretty. Iceland is also pretty. I would say Iceland is a very primordial beauty.
Oh, that makes
That's how I
sense.
would describe it. It feels
It's like
very
fire, ice, stone.
exactly,
air.
and
Yep.
it feels old. And I shouldn't have done this, and I hope I don't get in trouble for saying this. But at one point, I got a little bit lost in Iceland. You're driving for many, many hours, and I got a little lost. And I walked on a rock field, and the rocks.
How dare you?
Well, yeah, I know. Well, so the thing was, the rocks were breaking under me. Like it was a field just full of
Like
rocks.
pumice rock or something.
It's something, yeah, it's
Okay.
some kind of volcanic rock. And I was like, I guess I'm destroying this. But these were big rocks that were breaking. They were
That's crazy.
so fragile, so eroded
Did you
from
pick one
algae
up?
and stuff like that. I don't know if I picked them up to see how heavy or light they were, but
Okay.
they definitely like seemed mostly, well, you know what? I don't know. I don't remember. I should have picked one up. I don't know why I didn't pick it. It's like really obvious now. I guess at the time I didn't think, I should like take a mental measurement of the weight, but yeah, I don't know.
I do like that. This is a weird sort of side riff, but I really do like different density objects. It's something that just makes me happy. I've got 3 blocks on my desk that are all 1.5 inches. And I've got a tungsten one that weighs almost exactly 1 kilogram, which is like weirdly heavy for an object of this size. It's
For
a similar density to gold. There's
Yeah.
not many things that, depleted uranium, but I don't have that on my desk, obviously, would be denser, but not many things you can get
Right.
are denser than that. And then I've got a magnesium cube, which is the opposite end of the spectrum, the lighter structural metal that we have.
Really, magnesium?
Lighter structural metal, yeah.
Is that like similar to wood in how light
it's more
it
dense
is?
than wood.
It's more dense than wood. Okay.
Yeah, so wood varies wildly.
Yeah, that makes
obviously.
sense. That checks out. Redwood, very hard, I'm told.
Teak versus balsa wood.
Right.
It's a huge variety within it. But most plastics, water, are all about 1 gram per cubic centimeter, or 1 ton per cubic meter, almost exactly again as well. And then and temperature dependent and all that type of stuff too. And then magnesium is about 1.7. So it'll still notably sink in water, but it's really not that far off it.
Wow, huh? So you have magnesium, tungsten,
Aluminium.
aluminium, okay. And then, aluminium is lighter than magnesium. It feels really weird for me to say it like that.
Significantly heavier.
Aluminum, right?
Heavier than magnesium. Sorry, heavier than magnesium. Significantly so, actually. It's, Yeah, it's about 2.7 grams per cc. So it's, like 50% heavier, roughly speaking, than magnesium.
Very
as a pure metal.
interesting.
And then tungsten's, 20 times more dense than most plastics and water. And and what's that, 12, 15, something like that, more dense than magnesium.
Very interesting. Weird circle back, but Iceland, one of their industries is aluminum.
Yeah.
And so everywhere you go, there's aluminum, like bathroom stalls are like all aluminum and stuff like that. And it's really cool.
Very space age.
Yeah, it's very space age. Yeah. And I don't know. It's just it's really cool going to different places and seeing how different things are built because
How they make their bathrooms.
Yeah. I mean, it gets you into the mindset of okay, how is this made? It picks that kind of engineering urge to just understand how everything was put together.
I know, it absolutely does. You know why Iceland has such an aluminium smelting industry?
I do not.
It's their geothermal power.
Oh, really?
Yeah.
So it makes the cost of making the aluminum?
Exactly.
Oh, huh.
So with aluminium smelting, there's sort of roughly a third split of the bauxite input, the mining input, the other chemical operations, overhead, sort of bulk other category, and energy cost. And the energy cost is the most flexible in a lot of ways. Like bauxite is a bulk raw material. You can ship it from Brazil or Australia. And I think one of the Caribbean islands is a huge miner of bauxite as well, which aluminium hydroxide ore.
Yeah. Iceland also has this, I actually don't know if this is a factor at all, but, it's got all this portside property that, isn't necessarily your conventional beachfront property.
Okay.
You know what I mean? You're not going to, it might be a great view of the ocean, but it's going to get a little chilly. So,
so it might not be as great for housing as for industry, you're saying?
Right. Something like that.
That makes sense. Yeah, that makes sense. But the reason their electricity is so cheap is all their geothermal power. And so that drops the cost of energy enough that it's worth shipping all this bauxite, all like in bulk carriers, all from around the world to Iceland to smelt it and then ship it back.
Yeah.
So they have this huge surplus of aluminium. And the reason you need all this bulk power, because it seems like you just use solar or wind or some other renewables that solar power is the cheapest by a significant margin these days, right?
Yeah, that's true. There's a lot of space for solar panels if you wanted a really efficient operation or something, I guess.
Generally speaking. But with aluminium smelting, you need constant power because otherwise you end up basically either melting through your crucible because the flux that they use in the reaction is just so caustic that it'll destroy your reaction vessel, or the whole thing will freeze and crack. And so they need to keep it at this perfect temperature gradient where the core of the reactor is a liquid and the outside of it, the flux, is solid as a protective layer, and then you have your crucible itself.
Super interesting. So Iceland's advantage for smelting aluminum really is they have this constant supply of heat.
This constant cheap electricity. Yep.
So it goes to electricity, then back to heat. They're not using the heat directly.
No, yeah. It's an electrical process. It's electrolysis, just like you would split water. Yeah.
Gotcha. Very interesting. Yeah, I when I did this camper van around Iceland, there's really no tour guide. You kind of just get in a van and drive around.
Yep.
So we listened to some audiobooks, but they were mostly about Vikings and old Nordic stuff, I guess.
Yeah, fantastic. I mean, that's all super interesting stuff as well. Did you see a volcano?
We did. We even walked up to some active magma.
Oh, you got to see like the red hot lava spewing out.
Yeah.
Oh, incredible.
Yeah, it was pretty.
That's
it was
one thing
kind of
I've always
crazy.
wanted to see.
Yeah, it's weird because when there's a lot of it, they don't set up a perimeter or anything. If I wanted to jump in lava, I could have done it. It wouldn't have it was right there.
It's a very primordial thing of like you really probably should know not to jump in the giant hot melted rock.
Right.
And if you fail that test, let it be.
It's over. Darwin gotcha.
Darwin back with a vengeance. Maybe before jumping right into the office setup, which is sort of a time invariant thing, I've got two pieces of news at least.
Oh, hit us.
Okay, and maybe if you know any other news, that'd be fantastic as well. The first one is, do you know Lumen PNP?
Yeah, of course.
For those who aren't familiar with the project, it is a pick-and-place machine that is trying to drastically reduce the cost and complexity of assembling PCBs at home or in your office for prototyping and maybe low-volume production. But they really focus on the prototyping, making that really easy.
And they're building, so the pick-and-place is the thing that literally just picks up small chips and places them down where they go on the board.
Yeah, exactly. Sounds benign, right? But super critical to get really precisely right, because you think an 0402 resistor is absolutely minuscule.
Oh, so tiny.
Fraction of a millimeter in one direction and only just over in the other. And, the alignment matters. So you're going to start bridging your traces and your board just simply is not going to work.
Right.
And so really precise. They have sort of cameras integrated underneath to look at where the pads are. So where exactly the vacuum gripper has picked up this specific IC from where it was sitting in the reel, all that type of stuff. But Lumen PNP has just released their V4 machine today.
Oh,
really
I think
exciting.
I did see a snippet of this. Do we know what are the big features on the Lumen, the new Lumen V4? Is that what they're calling it, a V4?
The V4, it is. So I didn't get to see a huge diff in terms of the features, except for the speed, which was about 3 times faster. Huge difference there.
Whoa.
Very exciting in that one because it's always, you know, I don't know, my X1 carbon from Bamboo, for example, absolutely rips. Like the whole thing is like almost shaking the bench. You want to strap it down, right? It is going hard, and you're like, that is a hardworking robot. I would give it a tip if it made any sense.
So the X-Carve is a CNC. I also had an X-Carve like 10 years ago.
Sorry, the X1 carbon.
X1 carbon.
The X-Carve, yeah, different category. You had one 10 years ago.
So an X1 carbon is also a pick and place?
No, it's a 3D printer.
3D printer, gotcha.
Yeah.
Just me sorting out all the brands.
They all put X's and ones and carbon.
X is very cool now.
Back in.
Oh, this is so interesting. I'm looking for their announcement post.
So the other awesome thing about Lumen PNP, of course, is that it's open source, and they've also got open source feeders, which are really cool. They're just shy of $100 at the moment per feeder, which is like very, very good for a powered feeder in the industry. But if you look at the constituent components and assembly of this thing, it's, you know, the beauty of open source is I really think that the price of these is liable to drop by like another roughly 70 to 80% if someone decides to pick up an injection mold all these parts and have them manufactured.
That's right.
Elsewhere.
Do you know if you buy a Lumen PNP, is it going to come with some like some 3D printed parts or some like, you know, okay.
Yeah, it's kind of, I really like to draw an analog between it and like maybe the RepRap days of 3D printing. Mm-hmm. You remember the RepRap days, right? Like when you...
Oh, yeah, the very, very early 3D printer that was like, yeah.
It was like threaded rod and 3D printed parts you bought as a kit. And like, it was just ridiculous, right? And it's crazy because obviously like the industrial technology existed back then. We had 2D printers that worked a treat. They have all the same linear rails and stepper motors and like the whole shebang. Like we knew how to make this type of device back then.
Right.
But the like, let's say almost supply chains for the little guy didn't exist back then in the same way. So you couldn't necessarily access linear rails and threaded rods and blah.
That's right.
In the low quantities and volumes in order to prototype these things. So people were so creative in how they manufactured them. And everyone, the whole premise of the RepRap project is you were able to be able to 3D print another 3D printer, or at least all the constituent parts.
Right.
Which is really cool. And I think with Lumen PNP, we're now going from the RepRap days to the Ultimaker days, where you have a professional company selling for a few $1,000s a complete functioning device rather than just the constituent parts, and you really got to be a home gamer. And that's really cool. It's an awesome progression to watch.
Cool. I wonder where this is going to go with pick and places and just like small to medium assembly in general, because we were discussing this the other day at the Autopile office. We want quick turnaround, and it's worth so much to us to be able to get aboard same day. Mm-hmm. So there's that factor. And then there's also this kind of idea like where JLC is kind of winning is when you centralize everything and you have this kind of central place that all orders are going through, you can do pretty cool things to get things really, really cheap and fast, fully assembled boards fairly quickly. Mm-hmm. So I wonder who wins out. Like, will we see, because what kind of a dream for me would be a U.S. manufacturer so that there's not so much shipping that can do that kind of same thing as JLC. Yeah. But the inventory and all this stuff, like maybe that just never makes sense because you usually know a week in advance what parts you're going to use. So you can just get them in-house.
No, absolutely. You could defer the shipping. And, you know, obviously there's DigiKey and Mauser and they have warehouses here. Right. DigiKey is one of the top, it's one of the top 300 value privately owned businesses.
Really?
It's worth billions. It's a huge company.
Does DigiKey have any sub brands? Do you know? Like, or is it question. Like, are they, because I like, there's Mauser and DigiKey. Those are probably the two most used ones, I would guess.
Yeah, it depends a little on the country. You know, there's Farnell, obviously in China, LCSC as well, and a litany of others that...
Right. There's tons.
There's so many distributors. You know, you look through Octopart and you just continuously find distributors you never heard of.
But what I'm wondering is, like, if these guys are, you know, in the top companies valued, is it like kind of this fast drop-off? Is there kind of a power law thing here going on?
I think so. Because there's a huge economy of scale. If you want to... Like, there used to be a thing, and I guess there is still to some reasonable degree, if you're not on DigiKey, you don't exist from an electronics company's perspective.
Oh, huh.
There was a analog ADI rep that specifically said that to me. It was, it was a bit of a thing back then. And they actually asked me, is it now kind of the case that if you're not on JLC, do you not exist? And I don't think that's true yet, but I think that is looking forward the projected truth of the not too distant future.
Yeah, and there's maybe an asterisk here. If you're on JLC and stocked, because how much of their catalog is actually stocked? I think it's probably like 10% or something like that.
It's about there. We ran the numbers the other day, actually.
Oh, no way.
I can't remember. Yeah, so it's like 8 or 10%, I want to say. And then as soon as you count it stocked over like 20 components, something like that, it drops off even further.
Oh, wow. Yeah, I totally believe that. I'm constantly surprised when I look up like the most common like app mega or something, and I see it's only got like 200 or 500 or something. And I'm like, isn't that a problem? Like maybe those numbers aren't completely accurate or something, or maybe they're trying to work you into some like sort of like, pre-order, let us know ahead of time sort of situation.
But for 200 parts of those, like one of those app megas, just for argument's sake, say it costs them, I've got no idea what kind of spec IC you're talking about here, but let's just argument's sake say it's $1. If that component, in the volumes, they're talking about like 1,000, which isn't that many in the volume manufacturing terms.
Right.
So if you're talking about 1,000 of those for one compart and you've got whatever, 10 million components you could potentially stock. Your warehousing, both size and cost, adds up so fast. It's a pretty penny.
That's true. Yeah, it's all a scale game. It's like a completely different math game.
But if you kind of project through and you say, look, someone might want 5 boards tomorrow or the next day, and that's like, okay, we can make that happen. But if I want 1,000 boards, do I need to click my finger and get 1,000 boards tomorrow? Like, yeah, probably not. And so you can deal with the lead times on those a little bit more.
Yeah, that's true. I wonder how many. I wonder how many orders exist. Like, what the distribution would be if you looked at the 1 to 10 quantity orders, and then the 10 to 100 quantity, and then the 100 to 1,000.
Yeah.
And I would assume the most, not in terms of like number of boards, but in terms of like one click boards would be in the 1 to 10 category, but I don't know how much bigger.
Yeah, no, totally. Because you typically with high production boards, you're not going through a one click portal like that, right?
Right.
Because frankly, for mass production, there's just services that JLC don't offer at all, and they don't seem to intend to.
Really? What doesn't JLC offer? I hear about that. By the way, everybody tells me, I hear this so much. I like, it's crazy. Like, they're like, oh, you're using JLC, that's not serious or something. Yeah, exactly. And so I hear this all the time, but I don't really know the specific reasons, because I guess I haven't, you were at Tesla and doing like very serious boards and stuff. I haven't really done super serious boards.
Yeah,
so.
It goes both ways. So my opinion is more people have that attitude than have any right to.
Okay.
So it's the same in, you think of the like graybeard software engineer, and they're like, oh, you're using JavaScript to write a backend for your website? That's idiotic. Why don't you write it in C custom? And you're like, dude, come on. Like, we have the computing power these days that Python and JavaScript are a worthwhile trade-off to write a backend in.
Right.
Despite being interpreted and frankly, really slow in comparison to Rust, might be the new thing for it. But it's worth the trade-off. And that trade-off was more worthwhile than I often hear people, talk about. But conversely, like, if you're doing anything in volume production, you don't want to be programming these boards yourself or testing them.
Right.
And so if you were to go to a high volume, like CM contract manufacturer, like Jabil, for example, is a huge one, a couple of 100,000 employees. I think they have 200,000 employees globally. Huge company, right?
Yeah.
And they won't just manufacture your boards, they will test them and coat them and upload the firmware and check, run some device level testing for it, not just like the 4-wire probe traces stuff that has the checkbox in JLC, but actually validate that it works all up.
So does it come down to what your yield, when you start wanting to optimize yield, is it just that simple that you go to a contract manufacturer?
Yeah. Optimize yield, prove quality is probably the best thing. It's not necessarily improve, but definitely prove. And then there are some quality constraints that JLC is just simply not going to. Well, there's obviously the export regulations, but there's some other quality constraints that they're simply not tuned to. Like, if you want, highly impedance matched RF type stuff, potentially inadequate, let's say.
Yeah.
So
I wonder, what for each category of product, there's probably some acceptable percentage of defective units that are allowed to be sent out. Like a friend of mine did a mouse company.
Okay.
And it was probably like a pretty decent amount, like 1 in 100 or 1 in 200 were coming back defective, but they could just refund it and it was kind of no big deal. But for a Tesla, you would never do that. And that's got to feed into all the same stuff. So like depending on your category of product kind of says whether or not you can use JLC. For like a government drone or something like that, it's got to be 100% all the time, always, like everything tested 10 times over, I would assume. But
yeah. Well, it's also when you catch it has a huge impact on the rework cost. So if you get to catch something at the board level before you've, for example, conformal coded it, it makes the rework easy. And that rework might be justified depending on the value of that total board, so the number of components, the size of that board. And there are things you'll bother to rework, and there are things you'll just scrap and you'll accept the scrap rate on. Then once you conformally code it, okay, well, that rework's just got a lot harder, so you better be okay with chucking it out to at least a large degree, unless you're really under a time crunch. Now, once you've buried that in a product, perhaps you've sealed it into a battery pack and, like silicon sealed that battery pack closed, potentially laser welded a product shut. Yeah, like you're not reworking that, not realistically, not on volume. Like, don't be ridiculous.
What discipline is this? People who analyze each part of it.
Manufacturing engineering.
Engineering.
But like, depending on the company, the design engineers will get their hands dirty as well.
That feels like a role most people are probably hiring at like Series A, B. Like they've done some volume and they know the pains.
Probably even later. Like realistically, to get to the volumes. So this is the other thing about Teslas is like Tesla, for example, has one of the highest rates of some kind of defect, like in the car to the customer. And this is like, I'm trying to remember exactly the stat or where the stat came from, but it's one of the highest rates of defect to the customer. Yet it's one of the highest rates of customer satisfaction at the same time.
Yeah, how does that work?
Well, because they fix it. They say, oh, there's a paint blemish, no worries. We apologize. We'll patch it up.
Okay.
And also once you've owned a Tesla, you go sit in a different car and you're like, wow, this is quaint.
Yeah, you're not going to send it back. You're just going to get it fixed and get back on.
And you'll probably be stoked regardless. You just accept what's wrong with it as long as it's nothing like functional or large.
Are these like small defective things or like...
Often.
I thought Teslas were kind of hard to fix because it's like... There's like a lot of... what is it? Like the... not the body, but the frame is like it's like stamped or something, the chassis. But I guess there's probably not normally chassis issues. These would be different types.
Like I don't know, the most common things, it was even true in my car, is that the center console's like latch for when you latch it closed was just like you had to like really push on it to get the latch.
I see.
It's just little things like that.
Oh, interesting.
But
okay.
One of the like key insights that Tesla and I guess Elon has is that you can ship, and like Silicon Valley in general, really, so you can ship an imperfect product and it's still potentially an enormous upgrade for people, right? And so, perhaps often your perfection is your worst enemy, really, and you've got to be careful with that. And so it's the same sometimes in like, I don't know, your friend's mouse company. It's like, even if he was manufacturing tens of thousands of units, perhaps the net best option is still just to have customers test them and complain and say like, hey, sorry, it's defective. And he's like, I'm so sorry. I'll ship you a new one. No worries. Like that actually might not be insane,
Very interesting. I was hearing something about Tesla, and this is kind of related, but so I guess there's like a group of people on Twitter and they're saying like, oh, you should really have your desk in the factory on the shop floor because you'll just learn things. It's just like good to do that. I'm curious, like you were sort of building this AC unit at Tesla, the firmware for it and stuff like that. Would you have seen value sitting on the floor? Did you sit on the floor?
Yeah.
Oh, you did? Oh,
Not all the time. Not all the time. And I did at Lilium as well, actually.
Oh, really?
Yeah. No. I sat with the jet at Lilium like 30 meters away.
Wow.
30 yards for Americans. Yeah, no, it was super close by.
Thank you for that conversion.
Yeah, a really helpful conversion, I know. And then at Tesla, I didn't like primarily work out of the factory, but I was on site for significant periods. There was one time, like being on site is super valuable. You learn things you just couldn't otherwise. There was one time, I boss comes up, who was, I was responsible for the self-testing of this product, and my boss comes up and he says, like, hey, Matt, the reliability of these self-tests is like inadequate. We need it fixed by Thursday. The site's getting commissioned. Like, go make it happen. And if you don't get it done by Thursday, I'm sending you on site, which is for actually like the final site where you're actually putting the packs down and building out a site like that rather than the factory. It's like a little bit of a threat because you're typically in the middle of a desert somewhere. It's dusty, sunny. You've got like a generator running, ironically enough, because you need to like power all the laptops and stuff. And you can't drain the batteries because they need to sit there long enough to be able to self-power and protect themselves before you hook them into the grid. And you can't just like day one plug them into the grid, right? So it's funny, like you actually need to conserve the battery power of these enormous packs.
Oh, huh.
And so anyway, and this time around though, it wasn't the middle of the desert. I'm like, Yuval, you do know that this is Hawaii you're talking about.
Wait, they were sending you to Hawaii? So stuff is manufactured in Hawaii?
No, the site was being constructed in Hawaii, so they were dropping the packs off there.
Gotcha.
But the things that you kind of learn when you're there in person, it's awesome. Like, you'll learn that the internet connection is way slower than you bargained for because they're out in the middle of a field somewhere and the connection sucks. And some latency that you'd hard-coded into somewhere like actually makes no sense in this context. Or that maybe you need a Starlink to improve that. Or like there's so much you can do and learn with those people. And then there's the empathy that you gain from it. You're standing there next to someone and you're like, mate, this is like, yeah, I'm so sorry my test sucks.
Right.
Like, you're stuck here fixing this yourself. And like, yeah, I obviously should be in the trenches with you.
Yep, 100%.
Gain a lot from it.
Yeah, absolutely. It kind of reminds me of sort of the Autopile Friday kind of project day. If people are using Autopile, they're going to feel some of that user pain and stuff like that. Because I know when I'm like working on an auto router, like I'm not thinking about the big picture at all.
Yeah, you got to pound your own dog food, I think.
Yeah,
and if you don't, you're probably it's a huge trade-off, right? Because it's so time-consuming, right?
Yeah.
But also, if you don't, and you're not close to your users, which is the other thing that you really should be.
Yeah.
You don't know what you're doing.
It's just a lot of pain because every day you have to stare in the face the thing that is still not fixed. Right?
Yeah, that's the point.
thing that still doesn't work.
Well, go fix it.
Go fix it. Yeah. Very true, very true. But circling way back, Lumen PNP, their new Apollo?
Oplo, I believe is how they pronounce it. Yeah.
Are you thinking this might be the unit?
We've just bought one.
Oh, you bought one.
Yeah.
Nice.
I mean, like we literally just ordered it, so we'll be getting one of the new ones.
As soon as it came out. So you literally ordered today, is that right?
We actually had a heads up last night when we were planning to order one from someone.
Oh, nice.
One of the.
Oh, that's nice.
Anyway, so we deferred that to this morning.
That's awesome.
And got it, which is I'm so excited about. And yeah, we're going to give it a crack. We're going to see what it's like. And I'll report back in a few weeks when it's here and set up and we've like actually got a few boards through it.
Yeah. What do you have like a test board in mind? Do you have like a standard test board that you use for things or anything like that?
No, we typically design something from scratch for each.
Just do it each time because it's fast, right?
It doesn't take that long.
Yeah.
What have you made recently?
Well, we've been working on kind of a custom keyboard, but I'm constantly fighting the tscircuit auto router. Yeah, just like a 9-key macro keyboard. I want to...
Can you drive the trace? It's kind of like playing Snake, or...
It's supposed to be very fast, but... It goes very, very. The tscircuit auto router currently goes very fast, but it's not always right, and that is basically useless. You have to be, correct. You might not need to be fully optimized, especially for a keyboard, but you have to be at least correct.
Is it correctable? Like, are you able to edit the? Are you able to edit the layout after or in conjunction with auto routing in some way?
You can add trace hints. That's what we call them. So you click on a pad, you click somewhere else, and it'll auto route between points. So in theory, it's okay.
Yep.
But I want to be better, and it's actually kind of hard to be better because I was even watching some videos on KiCad, and now when you drag traces in KiCad, it even does a little bit of mini auto routing.
Yeah, it does.
Right?
And if you hit F, it'll finish and all sorts of things like that.
Oh, really? I didn't know that. Yeah. So the bar, like hitting that bar is pretty tough. But I will say the really cool thing about the keyboard is it's only like 80 lines of code because you're just kind of like saying the keys and then it calculates the positions and you're kind of good. So yeah, like there's some like electronics as code benefits to doing keyboards because they're so repetitive. It's just diode key.
Yeah, very, very cool. Very, very cool.
Yeah, what have you been building lately?
We just shipped a board that is going to be going into a satellite as a BMS, which is cool. It will be taking off early next year, I want to say.
Damn.
So that's pretty
Is that
exciting.
a JLC PCB? JLC PCB in space? No,
absolutely
Doesn't hit
not.
the tolerances?
No. Well, it's, when a launch costs like $1 million or whatever it is these.
Just spend that little extra.
Just, it's like kind of a marginal cost at that point. No. So definitely not for the mass production. But I mean, like you prototype the sub-circuits in it, and, like see how they go, and make sure, like sanity check yourself.
Absolutely.
Like, you wouldn't ship final code that you kind of slap together and have, no unit tests for, but you just gave one spin of an all up end to end, and yeah, same thing.
Is there a way to test an autopile board? Like, I don't know what you would test exactly, but I guess you probably do some like analysis, right? Like, do you know if chips are powered and stuff like that? Is there anything like that?
Yeah, so you can run some basic ERCs, and you can write additional ERCs relatively easily, and they fall into a few categories. You can do mathematical things, like based on assertions. You can say that whatever the voltage on some power bus has to be within some reasonable bounds, or outside of some whatever constraint you want to add. You can write heuristic-based things in the upcoming new core, not too far out here, fingers crossed. And these heuristics might say, well, you have a power thing connected to a signal thing, like that type, level of thing, and it's that's like weirdly valuable. It seems like heuristics are like, whoa, no, we're computers, we'll do everything perfectly.
Yep.
Like, no. If you're a computer scientist, you know how powerful heuristics are. So that's awesome too.
Yeah.
And then as far as like the actual the layout testing, it's not something we've focused widely on so far, but you can think how you reapply the same constraint-based, mathematical-based. You pick up the layout again and you work out, whatever it is, the impedance on a trace or the length of a trace and that type of thing. You feed it back into the equation and say, well, your crystal had to have 12 picofarad balances on it, and your trace is, adding an additional 6. And so you're way out of tolerance. So you can do a lot of intelligent things with that.
Yeah,
too.
I'm so excited for that because it seems crazy to me. I'm very excited for autopile to get into layout because it seems to me right now that those phases are completely separated in most programs. You do schematic, then you look at PCB. And I think there's like a little bit of a disconnect in some ways because I haven't seen this on a schematic. It might be there, but why doesn't a schematic just show like how long that trace is, for example, right? Because that's like relevant information. If you want to debug a circuit, right, without looking at a PCB, that would be relevant information I have on a schematic, but it never feeds back. It's just schematic to PCB. So I'm super excited for the integration of those things. And in Autopile's case, if there's no schematic, because you guys are kind of camp no schematic, if I understand correctly.
We think you should be able to visualize your designs, and a schematic is one way of doing that effectively.
Oh, gotcha.
But we look at it as an output, not a mechanism, like not a mode to describe your design.
Yeah, I think I agree with that, right? Like, because most people today would say the schematic is one of the inputs, and for both tscircuit and autopile, the code is the input.
Obviously,
schematic is just another output. And yeah, I guess it makes sense. Like, why use this kind of like particular, even what I'm proposing right now is kind of a different kind of schematic. So there could be so much innovation in schematic once it becomes an output.
Yeah, so much. And like you think of an interactive viewer, like you have, for example, you got an analog front end for some basic signal, like low speed stuff. Like no need to get fancy here. We're just talking about like an HVAC system for argument's sake, what I know. You've got a temperature sensor. Well, okay, so you've got a low pass filter and a buffer, like unity gain, and you've got some protection on that as well, current limiting resistors and some diodes to clamp it. And, then you end up at the micro. Well, okay, I want to view that chain. It's like a logical chain. And I want to view it like left to right as a page, as a block. But I might not necessarily design all of those elements in one module of code because there might be submodules or there might be some, patterning for loops. There might be something that's integrated into different IC.
Yeah, that's such a good point. If you're looking at, like we were talking about the Raspberry Pi and how good their PDFs are and stuff like that. If you were looking at a particular like system, that's kind of a good description. But if you were like looking at, if you wanted to see like the entire, I don't know, temperature control system or something,
Yep. The
you
power
might
buses.
show,
Yep.
you might show elements that go through many modules, but you won't show everything in every module. It's
Absolutely
just too
not.
much.
Exactly.
So yeah, that's a really good idea for kind of an alternate schematic representation. You might, if you're debugging, I'm just thinking about how cool the implications of this are. If you're debugging like a net, like you know that a trace is problematic,
Yep.
you might just want to see everything to do with that
Yep,
trace, right?
exactly.
What
Yep.
could this be capacitively
Yep.
coupled to? What are all the factors
You got it.
just on one schematic?
Exactly.
That's a great
just,
idea.
just with respect to one net.
Right, right.
And this is so cool when you integrate back in any testing data you have, right? Like, for example, say you've got some thermal feedback. You've got thermistors all over some debug board, or you've got whatever, a Saley plugged in. Well, this visualizer, you could reasonably like port that information into as well and have whether it's the currents flowing around and you have some visualization of that, or a heat map literally behind your interactive viewer of like what is hot right now. You know, you can think of there's so many more potent ways to interpret this data than these like glyphic paper-like constructs.
I love it. I wonder if we think about this in different ways, in the sense that what I like to think about is when I'm onboarding web developers to circuit design, which we've just started doing because we're kind of getting to the stage where you can make some things that might work.
Congratulations.
Thank you. But when we onboard them, they don't know so much stuff. And I almost want it to be like when you're using like TypeScript and it like gives you warnings and errors, and it almost kind of guides you to get to where you need to go.
Yeah,
so like they won't know that you need to do a decoupling capacitor, for example. So is there a way in this sort of schematic output to just show that that pin is noisy, right?
Yeah.
That something needs to be added there, and kind of hint to them, give them a little error, and then it's like, oh, you got to do that, and just guide them through each step of the process.
There absolutely is.
Yeah.
And there's also correct by design in that context as well. Whereas, you know, we've got now like an electrical power bus, and it can have the trait that it should be decoupled.
Yeah.
It's decoupleable. And okay, well, then the program goes through and decouples everything. Like, it's pretty simple.
Right, right. Like, why should the user even need to configure that?
No,
right?
Of course not.
There's no reason to.
No, don't be ridiculous. It's so ridiculous. Maybe back to the Lumen PNP for the third time. But it's, you know, you brought up before the speed of prototyping in the US in particular. But, you know, it's true for the rest of the world. Everywhere outside of Shenzhen right now has whatever, call it a 3-day delay behind the rate of iteration that they do. And if you look at that as a percentage, it's insane. It's a 300% delay compared to what you can do, because you can overnight boards if you're in Shenzhen.
Right.
Right. You, like the manufacturing and assembly, you can get it back in hand tomorrow.
Yeah, that's tough. That's tough.
We're dealing with 1/3 or a quarter of the speed that they are, at least, right? Because you're lucky to get a board back 4 days later here. It's probably going to be a week or so.
Yeah.
And so what does this type of in-houseable assembly, and like if you extend that to some kind of PCB manufacturer as well, what does that do? It's really incredibly... it incredibly changes your workflow.
Absolutely, absolutely. Just lowering that R&D cost of building new electronics, right? Because each of those 3 days delays are 3 days of labor cost, just not knowing if things are going to work.
Yeah.
Context switching.
There's a feedback loop here as well, because if you're saying, even best case, say it was for 3 days, but we know it's not. Typically in industry, you'll like 2 week spin, like is how long it takes to get your boards back. And then the bring up, because now it's, well, here's the loop. So say it's going to take 2 weeks to get your board back. Well, okay, well then it's worth investing in a couple of extra days to make sure it's right. So there's a couple of extra days before that. And you're going to do everything all at once, because you don't want to delay, you know, everything 2 weeks staggered. So you're making it all up board with should be right first time, first shot on goal, as they like to try aim at.
Right.
And then you've got the correctness before it, which means correctness before that. And it means a more complex board to basically bring up after that. You need firmware, you need to match with another team. Now you've got a PM that's coordinating 2 people. You're talking about like months-long spins, realistically, in most companies. And then everyone justifies why this system is correct. It's insane. It's honestly really stupid, in my opinion.
Yeah.
But if you bring that back and you say, no, 2 weeks, don't need any of that. Instead, you're going to get your board in like magical future 2 hours. For argument's sake, right? You're going to get it just the same as your 3D printed parts today. Like if you got like a fit check, or you want to try something, it's going to be 2 hours. Well, okay, I'll just do my power supply module and sanity check that I didn't have to pull the reset pin high.
Right.
Like I forgot to pull the reset pin high. Oh my God. And now you don't have to rework the dozen boards that you got from the manufacturer because of the delays. And you suddenly start working on smaller blocks and you try more you branch and prune effectively like you do in software.
Yeah, so it's really this exponential effect. When we lower turnaround, just the amount of innovation you can do, it could probably 10x's or something. It's just insane.
Yeah, because of those compounding feedback loops, which is, it's wild stuff. And I'm really looking forward to getting my Lumen in hand and having a play with it real soon.
And then what's your plan for the PCB? Still going to order those? Do you have like local people you want to work with to get those even faster too?
Yeah, we have both. So we are currently looking at ways to in-house fab the PCBs in like that hour scale. And we're going to see how that goes. That was part of this order. And there are a few ways to do it.
Can you share how you're doing that, or is it under wraps?
Maybe I prefer to talk about things that we've done or like are actually in situ.
Right. It's all speculative, right?
It's very speculative.
Yeah. It's like paying for like a really big thing, and then you're not totally sure.
Yeah.
We can't endorse yet.
We can't endorse anything yet. And it's just way more exciting to talk about like materially what's happened. So let's just leave it at that.
Right.
And then we've got the Lumen PNP, which even if you're just ordering raw boards, you can get them from like a quick turn supplier. Like there's multiple PCB vendors in the Bay, right? Like you can get some of them to, and they're great. Like honestly,
are they still like email first kind of people?
Yes.
Okay.
But they're so open to not being, like they don't want to be there. They just, so it's a like hill climbing kind of problem. It's like, okay, so this is where they've all ended up because it's what industry for the last few decades has made the most sense. Like they've got really great businesses. But then all of a sudden there's this outward force saying that you should be up here, but it's over this giant gully. Well, that requires an enormous amount of both like mental and human investment, social investment to change the way in which people work, and also just capital investment to get different equipment that excels in this quick turnaround type thing.
Right.
Now, the ones I've spoken to are more than willing to make that capital investment, but you've got to convince everyone involved that they actually want to do the thing. And how do you make a giant capex like that if your customers aren't begging you for it? And your customers aren't begging you for it because you don't have it, right?
Right. Yeah, it's hard to make the case. I've spoken to not too many contract manufacturers, but this is also something we're looking at doing. I even launched a site to probe manufacturers so I could send that. Yeah, circuit uploader.
Circuituploader.com.
.com.
Nice.
I always get the .coms.
Oh, you have to own the .com even if you don't use it as your primary domain.
Yes, but I built it just to probe contract manufacturers to see if it was something they would be interested in. And I actually didn't do tons of probing. Like I don't feel like I fully sussed it out. But one thing that was in the back of my mind, this kind of fear, is that they kind of like the quoting process, kind of like how salespeople would love to be on the phone with you, right?
Yeah.
And that hurdle, I think it's a difficult sales problem, but it's an inevitability. I think maybe getting them to accept this is an inevitability. Look, we're not winning. on this UX.
This is the hill climbing though, because if you have an individual in your organization whose responsibility is to make the sales, and you tell them to do the thing? Well, no, this is a salesperson. This individual is like, well, I like my job. I like talking to people. I learn so much. I bring value to this company. They want to feel resolved in their position, and they're like reasonable to do so. They're human. So can you cut past them? Well, that's going to undercut them and not make them feel great about their job, and cut them out of the picture as well.
Right.
Like this is a hard social problem.
Yeah,
it really is.
Yeah.
Seve, with that, thank you very much. I appreciate it.